Hello everyone, Miss Katongo here. We will look at physics related problems. Under these physics related problems, we will focus on simple harmonic motion. Before we look at the question that has been displayed, we are going to do a quick review on simple harmonic motion. So simple harmonic motion is the back and forth movement of a particle, in which a particle's mass is regarded, whilst the shape and the size is disregarded. Examples of particles that undergo simple harmonic motion is a simple pendulum, or rather a mass spring system. Okay, let's look at the question that has been displayed on the screen. A 0.25 kg block attached to a light spring oscillates on a frictionless horizontal table. So frictionless basically means that all the energy losses are disregarded. The oscillation amplitude, which is the maximum displacement of the particle A, is equal to 0.125 meters. And the block moves at 3 meters per second as it passes through the equilibrium at x is equal to 0. Find the spring constant K. So spring constant is basically the stiffness of the spring. So let's try to imagine this question that has practically been displayed by putting it in a diagrammatic form. We have a mass spring system with a particle which has a mass, and we have an equilibrium position there where we have our x being equal to 0. So this particle has been displaced at a maximum displacement, which is A being equal to 0.125 meters. Okay, and the question reads, and the block moves at 3 meters per second as it passes through the equilibrium at x is equal to 0. We know that at x is equal to 0, we have the velocity being at its maximum. Okay, so hence, if we have a maximum velocity, we definitely have kinetic energy. And since at its equilibrium position, we only have the maximum velocity, then the particle will possess some kinetic energy. And at equilibrium position, we have the mechanical energy being equal to the kinetic energy. So we can use this theory, rather, to solve the spring constant. The mechanical energy is given by half K S squared is equal to the kinetic energy, which is half mv squared. And in this question, we are basically looking for the K constant. So we can eliminate the halves by multiplying with a constant, which is 2. Hence, we'll have Ks squared being equal to mv squared, making K subject to formula. We'll have K is equal to mv squared over our A squared. We can do our replacement in here. We already have our mass being equal to 0.250 kg, and the velocity is practically given as 3 meters per second. And we have our amplitude being 0.125 meters. If we do our computation, we'll have our spring constant being 144 Newton per meter.